So the second half of 6.4 will be about using inverse trig functions. So yesterday's lesson, we talked about what inverse trig functions are, what are some of their restrictions in terms of domain and range. Today we'll actually utilize them to solve equations, solve problems. Now when it comes to regular trig functions, there are certain trig values for, quote, special angles that I expect you to know. For example, if I asked you sine of 30 degrees, I expect you to know it off the top of your head, not with the calculator. Same goes for 45 degrees, 60 degrees, and all the other angles that have those as references. Now, if I asked you to do a trig problem that doesn't involve a special angle, like 57 degrees or 23 degrees, then you'd have to resort to other resources. Now, if you were in school long time ago, that involves, looking up trig tables and looking up pages and after pages of numbers. Now, fortunately, we have calculators. The same concept can be said about inverse trig functions. If you are not evaluating an inverse trig functions at, quote, special ratios, side lengths like 1, 2, radical 3, that sort of stuff, then I expect you to resort to a calculator. But this does not mean we shut down our brain. The calculator is not a replacement for your brain. There is some things you have to consider. First, I suppose we should go over our lesson goals. So by the end of the lesson, we should be able to do, one thing. To use inverse trig functions to solve problems involving finding angles. Before we dive into some examples, I just want to refresh our memories on something, some key points that we need to remember. So key ideas from yesterday, from 6.4a. Recall that the range of the inverse sine function is from negative pi halves to positive pi halves. Or if you're so inclined, you want the degree system from negative 90 degrees to positive 90 degrees. I like to visualize this graphically. I remember it's from the first and the fourth quadrant. You need to remember the range of inverse cosine. That goes from 0 to pi radians, or if you are in the degree mode, 0 degrees to 180 degrees. Graphically, that's the first and second quadrant. And the range of inverse tangent, that is from negative pi halves to positive pi halves, exclusive, because those are vertical asymptotes. In the degree system, that's negative 90 degrees to positive 90 degrees. And graphically, that's the first and the fourth quadrants. This is imperative to know because your calculators are stuck to this. Your calculators are restricted to giving you outputs in these various intervals. So when you are using an inverse trig function to solve problems, you have to be smarter than the calculator. It's such an important idea, I'm going to write it down. Whenever you use inverse trig to solve problems, right? You need to be smarter than the calculator. You need to know what quadrants you want / need. In other words, we need to be smarter than the calculator. So let's start off with an easy example here. Suppose you were solving a problem, and the question asked you to find all angles between 0 degrees and 180 degrees that satisfy the following equation. tangent of theta equals negative 0.4. So the way you approach this is you approach it like a regular algebra equation. Let's disregard the fact that it's trig. Let's use algebra 101. The question says find all angles. Theta is an angle, so we need to solve for theta. Here is the theta right here. I hope everyone can agree that to solve for theta, to get the highlighted piece by itself, we need to undo the tangent function. Well, that's the job of the inverse, to undo things. So the first step here is to take the tangent inverse of both sides. So we'll do tangent inverse of the left-hand side equals tangent inverse of the right-hand side. Tangent inverse of tangent, they go away, they cancel out, and we're left with tan inverse of negative 0.4. Now, negative 0.4 isn't a special side length as far as we know, so we'll reach to our calculator, punch in a couple of numbers, and that calculator is going to give us negative 21.8 degrees. This here is a calculator answer. But it is not our final answer because it does not satisfy the requirements. What's going on here? Why did this happen? Well, if we recall that the inverse tangent function can only give answers in the first and the fourth quadrant. It's just bounded by those rules because humans, we created the calculators and they're bounded by this arbitrary restriction. So conceptually, this negative 21.8 degrees is the answer that our calculator gave us. But according to the instructions, we want our answer in this region here. Right. So notice what this guy says. This guy right here, this statement, says tangent inverse of negative 0.4. Says this guy should equal some angle where the tangent value is negative. Ask yourself, within the parameters of the question from 0 to 180 degrees, what quadrant is tangent negative? And after thinking about it briefly, I hope we all know that tangent is negative in the second quadrant. So although this is what our calculator gave us, the black angle, this right here is what we want. We want this answer. How do I find it? Well, what you have to do is you have to take the reference of the calculator answer, which happens to be the same, 21.8 degrees, but positive, and you place it in the quadrant that you want, 21.8 degrees here. So then that means our real answer, the answer that I want, in this case you can figure it out, is simply 180 minus. Right. So although this is what the calculator gave us, our actual answer is 180 degrees minus 21.8, which is about, I should probably use approximate symbols, which is about 150, 8.2 degrees. So that's all I mean by you have to be smarter than a calculator. Don't just be a robot pressing buttons and then accepting the first thing it shows you. You have to take a moment to pause and think, does my answer make sense? Does my answer fit in the quadrant that I want it to fit in? If the answer is yes, you go ahead and accept it. If the answer is no, you're going to have to move your answer to the appropriate quadrants by dealing with reference angles. So that's it. This is a very short lesson because it's all about you applying what we learned yesterday. But I do have a handful of other examples prepared. So if you feel like you got this already, you can skip the video. But let's continue on to the next example. Suppose I ask you to find all angles between 0 degrees and 180 degrees that satisfy, if I can spell, satisfy the equation sine of theta equals 0.78. So again, this is just a simple trig equation. To solve for theta, I have to take the inverse sine of both sides. So if I take the inverse sine of both sides, or the arc sine of both sides, we get theta equals sine inverse of 0.78. I'll reach for my calculator, and my calculator gives me an answer of about 51.3 degrees. 51.3 degrees. So this was our calculator answer. But I have to answer the actual question. Find all angles between 0 degrees and 180 degrees. Now notice what this statement says here. Sine inverse of 0.78, sine inverse of a positive number. So my question to you is, in the quadrants that they asked me from 0 to 180 degrees, what quadrant is sine positive in? Now, in this particular instance, sine is positive in the first quadrant, so this is good. This is a good answer. But we should know that sine is also positive in the second quadrant. So this equation is an example of a question that has multiple answers. It has two answers. The calculator answer that they gave us is perfectly fine, but we should know we want this answer as well. How do I find it? You take the reference angle, which in this case happens to be itself, 51.3 degrees, and then all you have to do is calculate from standard position. So if the reference angle is 51.3 degrees, the yellow-orange answer should be 180 minus 51.3 degrees. So in this particular instance, we must list two answers. I should probably use approximate symbols. It's about 51.3 degrees, and it's about 128.7 degrees, right? So just be careful. We know that we have two answers in this case because within the parameters of the question, because it won't always be 0 to 180 degrees, it'll be whatever it tells you. Within the parameters of the question, since this expression, this answer that we got, says sine must be positive, we know sine is positive in multiple quadrants, therefore we will have multiple answers. So just remember how inverses work. We take the regular trig function, a regular sine, a regular cosine of an angle, and it should give us a value or a ratio. So the inverse trig function, inverse sine, inverse cosine, inverse tangent, will take in a value, a number, a ratio, and it should spit out an angle. So the rule of thumb is, in any math problem, if we're solving for a length, you're probably going to use a regular trig function. If you're solving for an angle, you'll be using an inverse trig function. Let's just cap off this short lesson with nice, easy-peasy word problems, because all life is a giant word problem. Suppose I told you that a 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what angle is formed by the ladder and building? Our old friend, the ladder against a building problem. You guys probably did this a lot in 6.2b, the word problems section. As always, anytime it's a real world word problem, I always like to visualize it. I always like to sketch it out. So this is a standard setup. You have a building. Boom, there's our building. You have a ladder leaning against it. Here's a ladder, right? I suppose if you want to be artistic, you can, which I'm not, you can draw the rungs. There you go. What else do they say? It says the base of the ladder, the bottom of the ladder right here, is 6 feet from the bottom or the base of the building. So I know that this distance here is 6. I know that the ladder, I'm going to get rid of this because I can't draw. I know that the ladder is 40 feet. And I want to find the angle between the ladder and the building. So I want to find this guy. Okay. So just like in 6.2, to solve equations, specifically triangle equations, look at the information you're given. You're given the 40, you're given the 6. Then look at the information you're asked to solve for. I'm asked to solve for this angle. And then you ask yourself, how does everything relate to each other? Well, relative to this angle here, the 6 is an opposite, the 40 is a hypotenuse. Opposite hypotenuse makes me think of sine. So that's exactly what I'm going to write. Sine of theta equals 6 over 40. And then obviously you just take the inverse trig function. In this case, we're going to take the inverse sine. So I'm going to reduce just because I feel like it. 6 over 40 is 3 over 20. Take out my calculator. Now I know that inverse sine only gives me answers in the first and fourth quadrant. And typing this into my calculator, I get about 8.6 degrees. Now, my answer is 8.6 degrees here. Where else is sine positive? Sine is positive in this quadrant here. Now, does it make sense for the angle for this angle here to be our answer? That's about what, 171 degrees. Would it make sense in a real world problem for this to be 170 some odd degrees? No. So while technically this guy is an answer to this equation here, we have to disregard it because it doesn't make sense in the context of the problem. So in this case, we only have one answer, 8.6 degrees. So that's just little, I put this example here just to warn you that, you know what, you have to be smarter than the calculator. You always have to ask and check, is my answer reasonable? Do I have any other answers? Yes or no? So that's it, 6.4b, just applying what we talked about yesterday in the context of word problems now. So have fun, happy hunting.